Hi everyone, in this video we're going to look at these three problems. I'm going to explain the first one and you will then explain why the second and third one are so similar to each other. So let's begin. So here it's a rational function. This is a pre-calculus problem. And it is about figuring out where the function is undefined, namely function that is making the denominator 0. And the second part is distinguishing which one is contributing to be a vertical asymptote and which one is actually cancel out with a numerator such that it does not actually become a vertical asymptote. This first problem here is one with a 2 vertical asymptote. Second problem, I'm moving on to the second one there. Second problem, slightly different, but this one is written so that it does have one removable discontinuity, but it's not a vertical asymptote. That's what it's called. And third one here looks exactly the same, but this one is actually randomized. It could be 2 vertical asymptotes. It could be the one with the one removable discontinuity. So this is question coding area. Let's see how we are going to write those questions. Always begin with the selecting libraries correctly. This time it's going to have obviously multiple parts. So we're going to go down there and select multiple parts. And then I'm going to scroll down, show you the question part, and it states rational functions with a numerator and denominator. And I'm using these ordered list. It's an HTML code. Right, decrease the volume of the music, and here's a first item, and that's going to be a first item and the second item, and just like itemized thing in LaTeX, this is how you do it in HTML. And then we're stating the question, exact values, and first answer goes there, second answer, and third answer. These are all number type because I already gave the students that is going to be an equation form x equals there. So they're supposed to type in list of numbers. And it's nice so that this MyOpenMath system is set up so even though it's a number and they are allowed to, the students are allowed to type in D and E. So that's, I find it's a very convenient feature, though you don't have to do anything further. You can do that in number and calculate a number. All right, let's begin with the setup in the common control area. Numerator is going to be in this form, x plus b times ax plus c. Denominator is going to be in this form. This first case is where there is no common part, so there's no cancellation. So we're going to generate these random numbers a, b, c, d, f, and then we're going to expand it, and that's how we're going to display in the question text area. A is coming from 3 to 7, and B and C, they're coming from these negative number to 5, negative 5 to 5, and non-zero rand, that's the command, where we're making sure that A and A does not divide C. That's what it means. This is a variable C, and this is a variable A, and that means this one here means not equal to 0, and this means remainder. When variable C is divided by variable A, and this whole thing will spit out up to here the remainder. So remainder is not 0, that means it's not a perfectly divisible number. Now I'm preparing for the denominator, looking at like this. And this I forgot to explain because in my video series I never explained this useful feature. When you're selecting a random number, you can put a condition like this where, in parentheses, all the logical statements are connected with the Boolean operator. The same thing here, we're making sure that these two factors are not repeated because A does divide C and D does not divide G, it's going to have non-integer 0 there, and making sure and B and F are not equal to each other so they don't cancel out. That's what we're doing here. Make sure B and F are not equal to each other. And G and D is, sorry about that, G and D is not dividing. D is not dividing G such that it's not an integer solution, making sure it doesn't replicate it with this dx plus g there. So that's making sure that happens. So by choosing these 6 numbers in this fashion using this useful command where, and we can have actual 2 vertical asymptotes. In the next 2 problem, we're going to make these 2 things equal to each other so the something cancel out, and it has a removable discontinuity. Okay, I'm going to erase it. Now we're preparing the expansion of this x plus b and ax plus c. There, this a and b and c are ready. So if you expand that, the coefficient of x is going to be a times b plus c. The constant terminals will be this L. Leading coefficient is simply a. So this is a bit, I don't know, inconvenient part in this MyOpenMath, that you have to prepare it like this. You cannot put this expression right back into there as long as they're in between this quotation mark. It's going to express exactly in that form. For example, A and B and C are 3, 4, 5. Then it's going to write 3 times 4 plus 5 exactly in that expression, not simplified down to 2-digit number. So you have to prepare things like this for the display. That's a bit inconvenient part, but so we have to do that. And also we are preparing the coefficients of the denominator here and put it into nicer form. So again, this make pretty is a command where if this, for example, the coefficient of x is a negative number, then you don't mix plus and minus there, and make sure it's turning this expression to simply just -5 if this variable oi is -5. Just simply turn that into one sign and whatever other things that it does, and that's what this make pretty command is doing. So we have prepared this numerator and denominator. I'm showing you the question part there. So that's going to fill up the numerator and that's going to fill up the denominator. And we chose these coefficients in this way so that they do not have common factors. So in this case, it's going to be 2 vertical asymptotes. Let's go ahead and prepare that answer. Right, here it is. There's 2 vertical asymptotes are there. So the first one, vertical asymptotes A, is coming from the linear factor of a denominator. The second one is going to be the other linear factor with the non-integer 0. So to write it nicely, we're going to turn this one into a reduced fraction, and then it's going to generate string expression. Sorry about that. Now to display answer, first we have to determine the answer types. These are 3 multiple parts. All are calculated numbers. For all of them, the answer format is going to be list so that they can be listed. So in this case, there's no removable discontinuity. In that case, they will just type DNE, and then this list just takes care of it. And we want an exact form such that they don't put the decimal version in there. You can easily read from a calculator. So they need to calculate that. So I put the no decimal part in there. And in the question, I ask for them to have exact values. Answer box size is all the same. Now it's finally the answer. For all cases, these 2 vertical asymptotes is undefined anyway, and there are vertical asymptotes. That's the second part. There's a third part was about removable discontinuity, so I put the DNE in there. So this is the question where even though it's randomly generated, it is going to be always a 2 vertical asymptotes case. next case is going to be one vertical asymptote and one removable discontinuity. And the third one is a mix of these two things. So the main point of this question is, this video series is also to the third one. It's actually mixing these two conveniently. So this is a second question, and sorry about that, I wasn't sure if it's paused. So I apologize, let me begin again. Before we begin the next part of the questions, let me emphasize that this question is exactly the same. It's just a slightly different behind the scene thing that's going on. So this question part is exactly the same as before. So I need to explain the question part in here. The shape of this numerator and denominator is the same, and we choose a random number exactly the same, even though this is unnecessary, but I just go ahead and chose two different sets of three numbers, A, B, C, and D, E, F, and under this condition, there's supposed to be no cancellation. But here, I just redefine this D, F, G again in here, so I probably shouldn't have done that, or actually, I realize that it still needs to be there. So there are two things I am doing in here because there are two factors. I forgot about that. There's two factors. Either I want to make this one B and F equal to each other and cancel, or either I can make this dxg and ax plus c part, I can make those two part equal to each other. So I have two choices. So I'm making certain choices here with the 0 and 1. I'll go ahead and randomly choose 0 and 1. If it is a 0, I will cancel that x plus b or x plus f part. I'm going to make those two equal. If not, the other case, I'm going to make this a linear polynomial with a non-zero integers part 0, non-integer 0. That's what I meant to say. Non-integer 0 part cancel each other. So I think I'm doing this if command for the first time. So let me go ahead and explain that. This is how it works. You write if, and all the conditions going into this parenthesis. I chose indicator. If it is a 0, with this curly parenthesis, we'll do this thing and end the curly parenthesis. If not, you do whatever is in the second group of a curly parenthesis, all right? So if it is a 0, we're going to make that f and b equal to each other. In that case, you know they cancel out. The other one is a vertical asymptote, and this one in here, even though it's originally undefined, right here, it's going to be a removable discontinuity. So I'm defining there was a vertical asymptote and removable discontinuity here. If not, the other case, I am making this non-integer 0 part equal to each other. So D and G are equal to A and C. So the vertical asymptote is the other integer 0 polynomial, and removable discontinuity becomes this non-integer 0 part in there. So even within that, I make some random choices in there. So now we have all this thing ready, and it's just preparing this simplified version of quadratic polynomial is the same. So we have to prepare those coefficients, and this is changing the name, even though it doesn't really matter, to undefined points, right? Not necessarily vertical asymptotes, so I changed the name a little bit. Both of them in the denominator, they're undefined, so it's like that. Before it was a vertical asymptote A, vertical asymptote B, but here is undefined point 1 and undefined point 2. Answer type is the same. All three of them is calculated number and list and then no decimal. That part is the same as well. Answer box the same. This time the first answer slot undefined. That's both factors from the denominator. Vertical asymptote, there's only one vertical asymptote that was determined within that if statement. And here is removable discontinuity like that. So that's how you write this case where there is a one removable discontinuity. let's go ahead and take a look at the third one that actually randomly chooses both cases, and that's the interesting part. Okay, so let me explain it in this question list. What I just created was this 2 questions, rational functions with a no removable discontinuity case, 1 removable discontinuity case. The next part is going to mix up these 2. What I'm going to do is that the important part is that you got to prepare these 2 questions so that the question part should be exactly the same. Yes, that part is important. What we're going to do in that case, we can call these question number, question ID in MyOpenMath system. So this is a 413700, 413769. So in this next question, we're going to just randomly call this question ID and put it in there, and that is the idea. That command is include code from. So we have this 2 code. We want to either choose this question or that question. So if we run include code from 413700, and it's going to bring in everything that is in the common control area, not question text area, only in that coding part of the preparation part, and either call the other one. So we could use this random function, again, random from 0 to 1, choose either 0 and 1. If it chooses 0, that indicator is going to be 0, and then it's going to choose this first question. If the indicator is 1, and it's going to choose the second question. So it's going to bring in everything that is in that code, and there's nothing else is needed. As you can see, it's a clean 1, 2, 3, 4, 5, 6 line code. It's just going to bring in whatever is in that, and down there the question is going to be exactly the same. So if you run this question, then it's going to either generate, let me go ahead and make this one a little bit bigger. In this case, so let's see, in this case here we have 2 undefined points and the 2 vertical asymptotes, and there's no removable discontinuity. So I'm going to run this once again, and as you can see, there is a removable discontinuity in that case that was split up like this. So that's how you write questions like this. There are many cases this is useful. If you write the problems about quadratic equation, there's a single solution, there's a 2 solution, there's no solutions. And if you're doing law of signs over various different ambiguous cases, and you name it, calculus, whatever, there are many different cases of a polynomial case, or you can mix it up using exactly the same kind of question and coding, and you can mix up using this include code from. So that was it for today.